going to discuss about some of the important topics in design of steel structural elements. So first we should know about the basic terminology. So bolted connection is nowadays very important connections, and welded connection also. So this is a bolt. So in that this part is called as head, and this one is called as shank, and this one is called as threaded. So totally 3 parts are there. So compared to this shank area, this threaded area is very less. So this one is A, yes. A means area of the shank portion. So this shape is circular. So the area of the shank portion equal to pi d square divided by 4. As per the IS code, this threaded portion, the area of the threaded portion can be calculated AN equal to 0.78 times of pi d squared divided by 4. So the area of the shank equal to pi d squared divided by 4. Area of the threaded portion equal to 0.78 times of the pi d squared by 4. 3 types of bolted connections are there. The first one is unfinished, finished, another one is high strength friction grip bolt. So this both are similar, based on the finishing quality it is differentiated. So the surface finish is very good in finished bolt. The surfaces are very rough in the unfinished bolt. Now coming to unfinished bolt. So this is used for only the temporary connection. This is not a permanent connection. So welded connection is the permanent connection. Bolted connection is temporary connection. If we want, we can remove the bolted connection. So next one, it is only suitable for the static loading. It is not suitable for dynamic loading. It is only suitable for static loading. For the lightweight structure, we have to use only the finished bolt or unfinished bolt. This is made from mild steel. So mild steel means low carbon steel. Mild steel means low carbon steel. The ductility is more in the low carbon steel. So next one is, it is having diameter of M5 to M36. So M means mean diameter. So 5 means dia of the shank portion, not threaded portion, dia of the shank portion. So M5, mean dia of 5 mm to mean dia of 36 mm. So in the unfinished and finished bolt, load is transferred by bearing and friction. Through bearing and friction only the load is transferred to the plate. So here types of the bolts of property class 3 to 12.59 are available. So most commonly used bolts are 4.6 and 8.8. So here we can mention the grade of bolt 4.6 or 8.8. So what is this term and what is this term? So this term, for example, this is 4. So this 4 into multiply by 100, we can get 400 Newton per mm square. The unit is 400 Newton per mm square. Okay, so this is, what is the meaning of this 400? 400 is ultimate tensile strength of the bolt. The symbol is FUB. U means ultimate tensile strength of the bolt equal to 400 Newton per mm square. Example, if 8.8, this is 8.8. So what is this first one? This 8 equal to. So what is the ultimate tensile strength of 8.8 grade of bolt? So take the first term, this 8, and multiply by 100, we can get 800 Newton per mm square. Newton per mm square. So the ultimate tensile strength of the bolt grade 8.8 equal to 800 Newton per mm square. So what is this 0.8 and this 0.6? 0.8 and 0.6. So 0.6 equal to the ratio between yield strength of the bolt divided by ultimate tensile strength of the bolt. FUB FYB. Okay, FYB divided by F2B. Yield strength of the ratio between yield strength of the bolt to the ultimate tensile strength of the bolt equal to 0.6. So, coming to 4.6 grade bolt. Okay, so here 0.6 equal to FYB divided by FUB. We can easily find out the yield strength of the bolt. So, yield strength of the bolt equal to, we know this is FUB equal to 400. So, FUB equal to 400. So, 400 into 0.6, 240. So, 240 Newton per mm square, 240 Newton per mm square. So, this is the yield strength of the bolt. Okay, so this grade of bolt designated by ultimate tensile strength of the bolt as well as yield tensile strength of the bolt. So, next one, high strength friction grip bolt, that is HSFG. So, this is suitable for heavy loading as well as dynamic loading. So, here the load is transferred through the friction, not bearing, only the friction. This is made by medium carbon steel. Medium carbon compared to unfinished finished bolt, the strength of the bolt is more here because the carbon content is more. Medium carbon. So, compared to previous one, the carbon content is more here. In the previous one, that bolted connection, that unfinished bolt is made by only mild steel only, that is low carbon steel. So, available size is 16 to 36 mm. So, here this is designated by 8S, 8.8S and 10S. So, this symbol is embossed on the head of the bolt. We can easily identify. So, this comes under this high strength friction grip bolt. So, what is the meaning of this S? This S. S stands for high strength. S stands for high strength. So, next one, types of joints. So, basically two types of joints are available. The first one is lap joint, another one is butt joint. So, what is the lap joint? So, lap joint means two members to be connected or overlapped and connected together. So, see, this is one member and this is one member, both the member overlapped and connected together by bolted connection. So, here this is the line of load. So, this is one load and this is one load. If we apply the tensile force, see, some eccentricity will happen due to this eccentric load, because here line of action of load is not in the same line. So, see here, same line means this is the same line. Here one load is acting here, another load is acting here. The line of action not on the same line. So, it produces some eccentricity. So, due to this eccentricity, the bending will happen. How we can avoid this one? So, instead of providing one bolt, we have to give at least two bolts to connect the plates. Then we can avoid the bending effect. Next, coming to the butt joint. So, butt joint is classified into two types. One is single cover butt joint, double cover butt joint. Single cover butt joint and double cover butt joint. So, first we should know about what is butt joint. Two members, these two members are main members to be connected or placed end to end. So, this is one member and this is another main member placed one to one. This is to be connected by some cover plate. If we provide one cover plate on the top of the portion, top of this two plate, okay, it is called as single cover butt joint. If we provide another plate at bottom, so this type of joint is called as double cover butt joint. So, here see here, so here two contact surface is there. So, one is this one, another one is this one. So, two contact surface is there. So, here this is subjected to double shear, two shear plane. This is one shear plane and this is another shear plane, double shear. So, this single cover butt joint subjected to single shear because only one shear plane, this is only one shear plane is there. Coming to the double cover butt joint, two shear plane is there. This is one plane and this is another plane. So, here this type of joint subjected to double shear. Subjected to double shear. In the previous case, lap joint. Lap joint, here also only one contact surface, only one plane is there. So, lap joint is subjected to single shear. Lap joint is subjected to single shear. So, next one, some of the terminology we should know before designing the bolted connection. The first one is gauge distance. Gauge distance. The symbol is small g, gauge distance. So, what is gauge distance? It is the center to center distance between two consecutive bolts measured in a perpendicular direction to the applied force. See here, so this is the direction of the applied force. So, this is the direction of the applied force. So, this is look like a single cover butt joint. Okay. So, these are all the bolted connection. So, what is the definition? Center to center distance between two consecutive bolts. Two consecutive bolts means this one and this one. Center to center distance between two consecutive bolts measured in a perpendicular direction to the applied force. So, applied force is in this direction, perpendicular direction. So, this is G. So, this one is G, gauge distance. Okay. So, gauge distance means center to center distance between two consecutive bolts. So, this direction is perpendicular to the applied force. This is called as gauge distance. Now, coming to pitch distance. What is pitch distance? It is defined as the center to center distance between two consecutive bolts measured along a row of bolt. Otherwise, measured this direction is parallel to the applied force. The pitch distance means center to center distance between the two bolt. This is the center to center distance. Okay, center to center distance between the two bolt. For example, this is the center to center distance between the two bolt. So, this direction is parallel to the applied force. So, this is called as pitch. So, gauge means perpendicular to the applied force, pitch means parallel to the applied force. So, next coming to edge distance and end distance. Two distance are there, one is edge distance, another one is end distance. Edge distance means this last bolt is there, no, the center of the last bolt to the edge of the member. So, this direction is perpendicular to the applied force. This is called as edge distance. See here, this one is perpendicular to the applied force. This is edge distance. What is end distance? This is end distance. The center of the last bolt to the edge members. So, this direction is parallel to the applied force. So, this is called as end distance. End distance. This is called as end distance. Edge distance and end distance. So, nominal diameter. What is the nominal diameter of the bolt? So, always we have to take the shank dia as the nominal diameter of the bolt. So, dia of the bolt hole also very important. We can calculate D naught, that is dia of bolt hole equal to nominal diameter plus some clearance. This clearance value available in IS 800-2007. So, next one, these all the points are very important. The first one is minimum pitch. You should know about a minimum pitch, what is the minimum pitch and what is the maximum pitch distance. This specification available in IS 800-2007. So, coming to the minimum pitch distance, P minimum equal to 2.5 times of the dia. 2.5 times of the dia. Here D equal to nominal dia of the bolt. So, next one, maximum pitch distance. So, this is the tension member for the compression member. For the tension member, P maximum equal to minimum value between 16 T and 200 mm. So, first we have to calculate 16 times of the T, after that 200 mm. So, we have to find out which one is minimum. So, that value is the maximum pitch value. So, what is the T here? T equal to the minimum thickness of the plate. Minimum thickness of the plate. So, for example, this is one plate, okay, and this is one plate. The thickness of this plate is 10 mm and this plate is 8 mm. Okay, to find out the maximum pitch, this T we have to use 8 mm only, because T equal to minimum thickness of the plate. So, this formula is applicable only for the tension member. This condition is applicable only for the tension member. Now, coming to the compression member. Compression member, same thing. So, instead of 16T, here it is the 12T, 12 times of the T. T equal to minimum thickness of the plate. So, minimum value between 12T among this 12T and 200 mm. You have to find out this 12 times of the T, after that 200 mm. After that we have to find out which value is minimum. That value is considered as the maximum pitch. Now, coming to the end and edge distance. End and edge distance, both the symbols are equal, and that is E naught. Some of the textbook they have mentioned E naught, otherwise E also. So, here E naught equal to 1.5 times of the diameter of the hole. For the machine cut, okay, if you make the hole using machine means E naught equal to 1.5 times of the DH. This is minimum only, not maximum, this is minimum only. If you are using hand cut, 1.7 times of the DH. Okay. So, always we have to consider this one, 1.5 times of the DH while solving the problem. If it is not mentioned in the question, so we have to take E naught equal to 1.5 times of the diameter of the hole DH or D naught also. So, some of the textbook they have mentioned instead of DH, D naught. So, minimum pitch distance equal to 2.5 times of the D. So, this two thing is very important while designing the bolted connection. That is, first one is P minimum, another one is E naught, edge distance minimum, 1.5 times of the DH, this one is 2.5 times of the dia. So, next coming to here the partial safety factor of material. This is very important in the limit state method. In the limit state method, we are underestimating the material strength for safety purpose. So, always for the material strength we have to divide by some ratio, that ratio is called as partial safety factor. So, resistance governed by yielding, resistance governed by yielding means the symbol is gamma m naught. In that case we have to use 1.10. Next one, resistance of member to buckling. For the buckling 1.10, resistance governed by ultimate stress 1.25. Next, coming to the connection. So, for the friction type, shop fabrication and field fabrication, both fabrication 1.25 only. For bearing type means that is unfinished and finished bolt. Here also same factor, partial safety factor, and rivet also 1.25. Welded connection, for the shop fabrication 1.25, field 1.5, because there is a chance for error during the welding. So, the factor of safety is more in the field fabrication with respect to welded connection. So, next one, clearance. So, how we will find out D naught? Before that, so here, so this table is available in IS 800-2007, page number 30, class 5.4.1 and table number 5. So, next one, we can find out the D naught, size of the hole, that is D naught. This is D naught or DH, okay, D naught or D suffix H, nominal diameter of the fasteners means bolt only, plus clearance. So, here see this value we have to take, standard clearance, oversize we do not want, only we have to use this one. If the diameter of the bolt is 12 to 14 mm, 12 to 14 mm means clearance is 1 mm, 16 to 22 means 2, and 24 also 2, larger than 24 means 3 mm. So, which means less than 14, less than 14 means 1 mm clearance, and 16 to 24, 16 to 24 means 2 mm clearance, and greater than 24 means 3 mm clearance. So, this table is available in the page number 73, table number 19 in IS 800-2007. So, next one. So, we have seen what is the terminology, what is pitch, what is the gauge distance, what is the end edge distance, and what is the types of joints available, lap joint, butt joint, and the types of bolt, unfinished, finished, and high strength friction grip bolt. So, now coming to the design of bolt. So, always the bolt is subjected to two types of failure, one is shear failure, another one is bearing failure. So, first we have to find out the shear capacity of the bolt. So, this formula also available in IS 800-2007, shear capacity of the bolt. So, this is the formula, VDSB equal to VNSB divided by gamma MB. So, what is this VNSB? VNSB equal to nominal shear strength of the bolt. N means nominal, N means nominal. What is S? S means shear. Here B means bolt. Okay. So, nominal shear strength of the bolt divided by factor of safety. Factor of safety of the bolt. In the previous table we have seen gamma MB both sharp also and field also 1.25 only. So, what is VDSB? VDSB equal to design shear strength of the bolt, design shear strength of the bolt. Now, coming to VNSB. VNSB equal to FU divided by root 3 NN ANB NS ASB. Okay, same formula only. We know the stress equal to load by area. We have to calculate the load. Load equal to stress into area. This is the stress, this is the area. We are using some of the factor root 3 here. Okay. So, now what is NN and what is NS? So, NN means number of shear planes with threads intercepting the shear plane. For example, so just imagine this as a bolted connection, and this is threaded portion. Okay, this is a threaded portion. So, now consider the lap joint. Okay. So, number of shear plane with thread intercepting the shear plane. This is the thread portion. Okay. So, now for example, this is the lap joint. This is the lap joint. I think bolt length is very high. Okay. This is the lap joint. See here, bolt is having two portion. One is shank portion, another one is thread portion. This is the thread portion and this one is shank. So, we have taken the only lap joint. So, for the lap joint, the shear plane is only one shear plane. So, this is subjected to only the single shear only, single shear. This is for only lap joint. Okay. So, see here, there is two chance. One is the thread is passes through the shear plane. This is the one choice. The thread is passes through the shear plane. Otherwise, okay, otherwise this shank area passes through the shear plane. Okay, two thing is possible. One is, what is the one? The first one is thread area passes through the shear plane. This is the shear plane. Another one is the shank portion passes through the shear plane. Okay, if the thread portion passes through the shear plane, we have to consider this term. We have to consider this term, that is NN into ANB. So, this is the lap joint. For the lap joint, for example, this is the lap joint. So, for the lap joint, the thread portion is passes through the shear plane. So, which means in the lap joint the shear plane is 1. So, consider NN equal to 1. So, ANB equal to net area of the bolt. So, already I have explained the ANB net area of the bolt equal to 0.78 times of pi d square divided by 4. 0.78 times of pi d square divided by 4. Example, another example, if the shank portion passes through the shear plane. If you assume the shank portion passes through the shear plane, if the shank portion passes through the shear plane, this condition, if the shank portion passes through the shear plane, this term won't come, we have to consider this only. So, here number of shear plane passes passes through the shank area. So, here for the lap joint n is equal to 1, what is ASB, area of the shank, that is pi d square divided by 4. Okay, this is the general equation. So, based on the condition, we have to take this term or this term we have to take based on the condition given in the question. So, now coming to VNSB equal to nominal shear capacity of the bolt, that is Fu divided by root 3 Nn ANB plus Ns ASB. Okay, we can take any one term based on the condition given in the question, otherwise we have to assume, always otherwise we have to assume this one, this term only, assume the thread portion passes through the shear plane, because compared to the shank area, this thread area is very less, this only critical, always we have to consider the critical one. So, always we have to assume thread portion, thread area passes through the shear plane. So, next one coming to FU, this FU, so here one mistake is there and the code book itself, this is FUB, not FU, FUB. FUB means ultimate tensile strength of the bolt. So, here it is mentioned correctly, ultimate tensile strength of a bolt. Okay. ASB and ANB we know, net area and shank area. So, next one, while finding the shear capacity of the bolt, we have to consider another 3 terms. The first one is long joint, another one is long grip length and packing plates. So, based on the condition, some of the reduction factor we have to add while finding the shear capacity of the bolt. The first one is long joint. What is this one? Long joint, that is the distance between first and last bolt in the direction of the load exceeds 15D, the distance between the first bolt and the last bolt. Okay, this distance greater than 15 times of the diameter of the bolt. Okay, so this condition is satisfied means we have to use this reduction factor. Okay, so due to this long joint, the shear capacity of the bolt will be reduced. So, L greater than 15D, L greater than 15, what is this L? The distance between the first bolt to last bolt. If the L is greater than 15 diameter of the bolt, D means nominal dia of the bolt, we have to introduce one of the factor, that is beta Lj, long joint. This is the factor, that is 1.075 minus Lj divided by 200D. Okay, so this one we have to use to find out the reduction factor. So, this reduction factor we have to add additionally in the this formula. We have to add additionally, we have to multiply additionally here. Okay. So, this value, after finding this beta Lj, this value in between this value means okay. For example, if it is 0.65 means we have to take, okay. If for example, the beta Lj is 1.2 means we have to consider only one value. This is the minimum value. So, next coming to the second reduction factor, that is large grip length. Okay. Already we have seen the grip length in the first slide, that is the symbol is Lg. So, here the grip length exceeds 5 times of the diameter. Exceeds the 5 times of the diameter, we have to introduce one more factor, that is beta Lg. So, this is the formula 8D, nominal diameter of the bolt, divided by 3D plus Lg. So, this beta Lg shall not be more than beta Lg, we have to check this one also. Another one is packing plates. So, packing plates, this is the third reduction factor, third condition. This packing plate we have to use in the butt joint only. So, this is one of the main member and this is another main member, but the thickness of this two main member is different. For this is 20 mm and this is 10 mm. For example, this is 10 mm. How we can connect these two main plates by cover plate? We have to introduce one more packing plate here. This is the packing plate. So, after that we have to provide cover plate. This is the cover plate. Okay. So, now so what is the thickness of this packing plate? This is 20 mm and this is 10 mm. The thickness of the packing plate is 10 mm. So, here the packing plate is excess of 6 mm. The packing plate thickness is greater than 6 mm means we have to introduce one more reduction factor, that is beta pk 1 minus 0.0125 thickness of the thicker packing pk. Okay. So, here in this case the packing plate is 10 mm. So, this comes under this category because the thickness of the packing plate is greater than 6 mm. So, we have to calculate this reduction factor. Due to this packing plate, the shearing capacity of the bolt is decreased. So, we have to add this reduction factor in this formula, that is beta pk packing plate. So, next one. So, I told the bolt is subjected to shear as well as bearing failure. So, first we have to find out the shear capacity of the bolt, another one is bearing capacity of the bolt. So, strength of bolt equal to minimum value among shear capacity of the bolt and bearing capacity of the bolt. Okay. So, how we will find out the strength of the bolt? So, always the strength of the bolt subjected to two types of failure, one is shear, another one is bearing. So, first we find out the shear strength of the bolt, next we have to find out the bearing strength of the bolt. After that we have to take the minimum value, that value as considered as the strength of the bolt. So, how we will calculate the bearing capacity of the bolt? So, this formula, this formula is available in IS 800-2007, that is VDPB equal to VNPB divided by gamma MB. This is design bearing capacity of the bolt. D means design bearing capacity of the bolt. This is nominal bearing capacity of the bolt. This is factor of safety, partial factor of safety of the bolt 1.25 only. So, nominal bearing strength of the bolt equal to 2.5 times of KB DTFU. So, this is factor. How we can find out the KB? KB equal to, so here first condition, second condition, third one and fourth one. So, among this fourth we have to select minimum one, that value is considered as the KB value. So, now what is E divided by 3D naught? E means we know edge distance. So, what is edge distance? If it is not mentioned in the problem, edge distance, minimum edge distance we can calculate. The minimum edge distance equal to I think 1.5 times of the diameter of the hole, 1.5 times of the diameter of the hole. We will check. Yes, 1.5 times of the, see here minimum edge distance or end distance equal to 1.5 times of the D naught. So, 1.5 times of the D naught, E equal to, so E equal to 1.5 times of the D naught. Okay. So, how we will calculate the D naught? D naught equal to diameter of the bolt plus clearance. So, now coming to second one, second condition is P divided by 3 D naught minus 0.25. D naught we know already, we have calculated here using this formula. What is P? P equal to pitch distance. If it is not mentioned in the problem, we can find out the pitch easily. This pitch is minimum pitch 2.5 times of the nominal dia of the bolt. So, pitch equal to 2.5 times of the nominal diameter of the bolt. So, after that coming to this one, FUB divided by FU. So, what is FUB? FUB means ultimate tensile strength of the bolt. FU means ultimate tensile strength of the plate. Okay. So, here there is no B in the suffix. If B in the suffix means that is the respect to bolt only, that is ultimate tensile strength of the bolt divided by ultimate tensile strength of the plate. Okay. So, next one is 1. So, first we have to calculate this value, second and third and fourth. After that we have to select the minimum, that value we have to substitute here, K suffix B. So, next one D. D equal to diameter of the nominal diameter of the bolt, and T equal to minimum thickness. What is F? U, Fe equal to ultimate tensile strength of the plate. Okay. So, after finding this one, substitute here and divide by 1.25, we can easily find out the VDPB. After that, find out the strength of the bolt using this condition, minimum value among shear capacity of the bolt and bearing capacity of the bolt. Okay, we will see in the next class.